High potential, gathered together in small focus in a searchlight, for example, will cut a visible luminous streak through the low potential of the air, an incandescent path against the night sky. This streak of light reverses the negative low potential of the illuminated area, increasing its positive charge. The temperature of the path of light decreases in direct universal ratio as the distance from its source increases. Decrease of temperature is an expansion pressure dimension. The radioactive emanations leaping violently from the sun with the explosive force due to great pressure from behind develop incandescent streaks of light for millions of miles. These streaks of light form what is known as the corona of the sun. The violence with which they rise directly away from the sun produces a state of incandescence, which disappears only when the radioactive emanations find the equilibrium pressure of their potentials and float in west to east orbits around the sun. The temperature of the corona rays decreases in universal ratio as their distance from the sun increases. The corona ray and hydrogen flame rising from the sun are effects of radiation, the exact opposite of that of a meteorite falling to the earth, but the reason for their incandescence is the same. Every element has its own equilibrium pressure, therefore, every element has its own melting point. More than this, every planet of every atom has its own equilibrium pressure, and therefore also has its own melting point for its mass and for each one of its elements. The active force which compresses great volume into little volume and registers the intensity of that compression in heat is the male electropositive genero-active force of inhalation. The reaction force which expands little volume into large volume and registers the intensity of that expansion in cold is the female electronegative radioactive magnetic force of exhalation. Exhalation is an exothermic force. That means that it is heat releasing in the commonly accepted scientific sense. Heat releasing in the true sense means the redistribution of accumulation of heat over a large area, the constant being unchanged. When heat gathered from a large area has been compacted into a sufficiently small area to cause a violent impact of opposite pressures seeking equilibrium, a state of motion is produced known as luminosity or incandescence. The nearer the equalization of increasing pressure, the greater the luminosity. The vortex of any system is always luminous. It matters not whether the system is of low potential and pressure opposition or of high potential and pressure opposition. There is always a sufficient pressure opposition at the vortex to cause a state of incandescence. It must be remembered that the melting point of low potential is correspondingly low and that melting points rise as opposing pressures increase. The state of violent motion which produces incandescence at the nucleus of the hydrogen atom is as relatively violent as the state of motion which produces incandescence in the sun of the carbon atom or the sun of our solar system. The law for little mass being the same as for big mass, it follows that each planet in this solar system must have its own melting point as a mass and its own relative standard unit, melting points for every subdivision of its mass. Now I want to read what is on the page called the Solar Mystery, this chart you see here. It says on here, the positions of magnetic poles, magnetic bases, the gravitative and the radiative centers are not as fixed positions in the sun as they are in more rigid bodies. The contraction and expansion of the non-rigid belt because of solar inhalation and exhalation are balanced by equalizing contraction and expansion of the polar magnetic bases. This is chart number 2, the breathing of the sun, explaining the periodic variations of the solar corona in conformity with the changing magnetic basis and ecliptic plane of the sun. So that was what is on that page. The opposing pressures, which would melt a mass of zinc into a liquid, for example, would not even affect the rigidity of a mass of carbon rhodon. It can readily be seen, therefore, that a temperature which would be extremely hot to the mass of zinc would be but a warm breath to the mass of carbon rhodum or something. It is these relative temperatures, densities, and pressures which lead us to form wrong conclusions regarding the relative temperatures, densities, and pressures of the planets of this system. The relatively expanding mass of this planet could not stand the heat of the pressure zone in which Mercury floats. This planet would become a molten ball in Mercury's orbit, whereas Mercury's rigidity is hardly affected by it. On each planet of this system, the degrees of heat and cold measured in their own relative standard units are so varying that one cannot judge of conditions on any other body when measured by standards common to this body. On Mars, we see polar ice caps, and we assume that the temperature must drop below the 32 degrees to which we are accustomed as the freezing point of water in order that the ice caps could be possible. As a matter of fact, water on Mars would not freeze at 32 degrees. It would require a very much lower temperature. An atmosphere which would be too cold for us to survive would be comfortably warm for Martians. We see the red fire spots of Jupiter and assume by our standard units of heat that Jupiter must be very hot, whereas, on the contrary, it is relatively very cold. The heat of a flame at the surface of Jupiter would be below the freezing point of water on this planet. The rings of Saturn, judged by our standard units of density, are presumed to be composed of solid substances like what we are commonly known to us as boulders. The rings of Saturn are composed of solid masses, but the solidity of Saturn's rings would be as a heavy, smoky vapor to us. The outermost planets of this system and the nebula beyond them are of so much lower pressure equilibriums that states of incandescence, which would be extremely hot for their potentials, would be colder than liquid air to us. It does not require much imagination to visualize a condition of relative heat on the planet Neptune when one considers that hydrogen freezes into a rigid solid in the ordinary temperature of Neptune, whereas on this planet its freezing point is 250 degrees Celsius. It is perhaps difficult to realize that substances sufficiently solid to be used as building materials on one planet would be liquids and vapors on another. The very bricks and iron beams we use in our structures would be but liquids to the inhabitants of Mercury. Conversely, frail substances to us would become the staunchest of building materials to the possible inhabitants of Saturn or Uranus.